Hey everybody, this is Larry. This is day 21st of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button when my computer loads. And yeah, leave me a comment on what you think about this problem in this video and all the loading and stuff. Today's problem is to a one bitwise n of numbers range. Given two integers left and right, representing the range left-right, return the bitwise n of all numbers in this range inclusively. Okay, I mean, I think this is kind of a cool problem, but yeah, but I mean, most answer is going to be zero, right? Just because, well, because it is. But okay. So I think the idea here is kind of, I mean, there are a couple of ways you can think about it, but obviously doing a for loop is going to be too slow. So, so maybe if you do it intelligently, it'll be okay. But okay. But so the idea here I may play around with, and maybe I'll play around, is that the first thing to do is like you have adjacent numbers, right? And this is a range, so there will always be adjacent numbers unless you have one number. So what happens if you have an odd and even number, right? So if you have an odd number and an even number, then that means that the last digit is always going to be zero. So then that because when you do a bitwise and it'll be zero, right? So that's one, and then the rest you can go. So then the question is then, I think the idea for me then is think whether there's um, is that given a range, we can probably actually do this recursively, right? Let's say we have a range, and this, we only look at adjacent numbers, but we can actually create like any, well, maybe not 3 because it's a binary number, but so let's say it's between these two numbers, then you can figure out sort of pigeonhole kind of thing, right? So between these two numbers, we know that, or like the last digit, we know that, okay, they're both zeros, but we also know that from the previous things that there is well, there's a 0 and a 1, and as long as you have really 1 0 in that range, then, then the entire thing is going to be 0. And then maybe you could do it recursively where you go, okay, now you divide it by 2, and then you have these two numbers, and then you go, okay, well, is there a 0 in that range? Yes, right? So what happens is that there's no 0 in this range, only if, well, if they're both 1s, so maybe we look at here, and also, well, in this case, there is going to be a 0 inside, so the only case is that the prefix is the same, right? Because if the prefix is, well, yeah, only if the prefix is the same will you have, so basically it's almost like a common prefix thing, maybe. To be honest, I'm not quite sure about this one. Let's say you have this, right? Then that means that no matter what, even everything to the right of it is going to be have a 0 in it. So it really is just coming down to the prefix, isn't it? So I guess that's pretty much it, right? Maybe, right? That's my hypothesis. Maybe it's wrong. Um, but yeah. So how do I want to write this, right? Then here, then we have, we convert it to binary. We can convert it to binary. Um, but they may have different lengths, so that's a little bit awkward. I think that's a pad thing, right? Is Python of a pad thing? Python. Oh yeah, I guess it's using F string. You could pad it with F strings. Right? Oh, Z code. Huh. I don't know if it's F code. Something like that. So right is probably gonna be the bigger number no matter what. Or longer. The number of more digits. I mean, it's gonna be a bigger number. So Z still. Later, yeah, something like that. I don't know why my computer thinks so slow. Maybe it's my browser. Maybe I have to restart my computer. Anyway, so you have this. So then now we just return the prefix, right? Maybe. that, or like as many things as it is equal. So now n is equal to right. Just create this. And now we're going to do like right? If R of I is not equal to L of I, then so maybe current is equal to 0, and this is a prefix, right? So then we return current. Otherwise, we want to, then this is a 1, so then we just kind of like this. 1, 2, 2, 2, 2, and minus 5 minus 1 or something like this, right? And then we can clear out. Something like that. Apparently it's wrong though. Why? Yeah, let's put it out there. Maybe I should see that. I mean, I think the idea is probably right, but maybe the oh, because there's a P. Oh, I got by 1, but still. Oh. Okay. Oh, oh, whoops. This has to be a 1. So yeah, okay. So I guess technically you would just do it. What happened to the zero? I think the zero is fine, right? Like, I actually think this one see a little bit. But basically, you have something like do, 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 and then like some other stuff afterwards. This prefix is fine, right? And even this is fine. So the zero is fine. So then we want this is going to be okay, if of I is equal to 1. The way I write this is very awkward, but I think that, but the idea is more important to me. So we'll see how this goes. And it's pretty good. I'm just kind of, I think, where am I running with that? I mean, anyway, but these inputs are pretty basic, so maybe we have to think about something more. Like, oh, the error. I mean, it looks okay, so let's give it a submit. And there we go. 1422 days 2. Pretty good. This is going to be linear time. Right? How did I do last time? I did do recursively last time. Kind of what we said about earlier. Because I think maybe cleaner, I don't know. The time before that, yeah, I guess today I did it. I mean, today I restored that solution, but then I kind of jumped ahead a little bit. But yeah, this is linear time because linear is in the size of the input, and the size of the input is the number of bits. So this has n bits, this has n bits, and we therefore loop on n. So pretty much, well, okay, maybe this is n squared because of the way that we do a right shift. If you really want to be precise, we probably can change that in a cleaner way. But yeah, so maybe it is n squared. But but you probably could change that so that is 1 to n. Maybe I don't know. It depends how you want to define things really exactly. But technically speaking, even without the shift, if you really want to be precise, the or equal to already has it's going to be linear because that's how bitwise operations work. But I don't know. I mean, there are ways you can do it, but it's just a little bit awkward. Like you can convert, you can have the string and then actually convert it one loop altogether. It's still there. So I don't know. Depending on how pedantic you want to be. Anyway, that's all I have for this one. Let me know what you think. I'm going to do an extra farm after this. But yeah, thanks for watching. Stay good, stay healthy, be good mental health. I'll see y'all later. Take care. Bye bye.